Welcome to Real Civil YouTube channel. In this video, I am going to discuss with you about static analysis versus the dynamic analysis. Okay, so what is the basic difference between the static analysis and the dynamic analysis, right? So before understanding the analysis, we need to understand when we call the load applied is a static load and the load applied is a dynamic load. That concept needs to be very clear. Okay, so in your mechanics strength of material, you may have seen such a type of problems where a simply supported beam subjected to point load at the center. Okay, and then we just go on solving the problem using equilibrium conditions, right? But nobody has told us how the load has been applied here. Okay, so I will give you four options A, B, C, D, and you have to tell me when we call the load or when we call the load as a static load. Okay, so you can see there are four options. Okay, I will tell you the answer. In case A, the load is suddenly applied in the system. Here you can see, and then it stays in the system, right? In second case, again the load is suddenly applied and the load intensity goes on decreasing, and after some time the load becomes zero. In case C, the load is again suddenly applied, it stays in the system and then it comes to zero suddenly. That is the case C. And in case D, you can see the load is applied with a very slow rate, and when it achieves the full capacity or full load, then it remains in the system. Okay, so this case number D, we can say this is the static load case. Why? Because in our system the load is not suddenly applied, the load is applied with very slow rate, and when it achieve or attain the full load capacity, then it stays in the system. In other cases like A, B and C, you can see the load is suddenly applied. Okay, so when the load is suddenly applied, or there is another term, so here we can say this is the rise time TR. Okay, if the rise time is very less, then we called it as a dynamic load, and if the rise time is much more, then we can call this as a static load. This is one parameter for deciding the load, static or dynamic. Okay, there are other factors also like stiffness, flexibility, etc. Now let's move on to our topic. What is the difference between the static and dynamic analysis? Okay, again we are taking the same example, a simply supported beam carrying point load at the center. Now you know in static the force is constant over a time and the rate of loading is very small. As you have seen, that rate is very small, and then whatever load is there, it stays in the system. So this is, we can say this is force and this is time. Okay, so slowly applied load and then it remains constant. Okay, so such types of problems can be solved by using equilibrium conditions like summation fx is equal to 0, summation fy is equal to 0, and movement at any point is equal to 0. Or you can go with force displacement relationship, or you can use the compatibility condition. Okay, one thing you have to notice here, as the force is constant over the time, the response is also constant. Here response means I want to say like reaction, displacement, deflection, or even stresses, strain. Okay, as the force is constant, the responses are also constant. So that is the static case. But what happened in the dynamic case? Here you can see one loading is shown here. Here this is the force and this is the time, right? So you can see at every instance the force is changing. Okay, every instant the force is changing, right? That means force is varying with time. That's why our response is also going to vary with time. So that is the basic difference between these two. Okay, now you may think we can solve each force we have to consider and then we will use the static equilibrium condition and let's solve the problem. But that is not the case. You cannot use the equilibrium condition or static method to each frame. Okay, why you cannot use? Let me explain. Now once again come back to the point of static analysis. Okay, as I told you, the force is constant. Okay, as force is constant, whatever displacement of the beam is there, that displacement is also constant. If the displacement is constant, then there will be no velocity and no acceleration. So that is our static case. But what happened in dynamic? As you can see, our force was varying with time. Because of that, our responses are also not constant. So displacement is also varying with respect to time. As displacement is there, we can find the velocity by derivating. As there is a velocity, we can find the acceleration again by derivating. Okay, so that is the main thing. In static analysis, there is no velocity, there is no acceleration, but in dynamic load there is an acceleration of that object, or here in this case the beam is vibrating, the beam is experiencing acceleration. So how to solve such a problem? For that, we need to review the Newton's laws of motion. So what is the first law of motion? Any object will remain at rest or in uniform motion unless acted upon by the external force. That means if the object is at the rest, that means it is at equilibrium. As it is at equilibrium, that means there is no any unbalanced force, right? As there is no any unbalanced force, as it is in a rest, that means it is in the no, it is not in the motion. As it is not in the motion, there is no any acceleration, right? Second, Newton's second law of motion, which tell us if there is an unbalancing force in the system, then it will accelerate the object, and that unbalancing force to accelerate that object will also depend upon the mass, right? So we can say F is equal to ma. Now if you consider one system in which, say, forces are acting F1, F2 and F3, right? If the motion is at the rest, that means F1 plus F2 minus F3 will be equal to 0. That is our static analysis case. But in dynamic analysis, what happens? F1 plus F2 is not equal to F3. That means there is some net force is acting on the body. As there is a net force, as there is an unbalancing force, that means your object will accelerate, right? As our object is accelerating, which is having something mass. Okay, so how to solve such problem? For that, we have to use the D'Alembert principle. So what D'Alembert principle says, if your object is experiencing a net force, then you have to apply one fictitious force, one imaginary force, one pseudo force. He called that force as a inertia force, and that force must be equal to mass times acceleration, means mass of the object and acceleration. Okay, then we can have the dynamic equilibrium, right? So F minus ma is equal to 0, and in static case this ma, that is, as there is no any acceleration, this term was getting 0. So I can say static analysis is one type of dynamic analysis in which the external pseudo force or the imaginary pseudo force is 0. So let's summarize. In static analysis, we can use the equilibrium condition as there is no any unbalanced force. As there is no any unbalanced force, there is no any acceleration. But in dynamic analysis, we have to consider, as our body is experiencing inertia, we have to consider, as our body is accelerating, we have to consider the inertia force, which is equal to mass time acceleration, so that we can have the dynamic equilibrium. Okay, so that is the basic difference between static and dynamic analysis. I hope the concept is clear. If you have any doubt, you can ask me. Thank you so much. Please like, share, subscribe the channel. Thank you so much.